Okay, so welcome. Thank you guys for joining us. This is 3D printing, the introduction to 3D printing and design. I am currently sitting here in the shop. My name is Gabby. I work here full time. Normally the shop would have been open through for a few hours a day for what was called open lab. So you were able to come in and check any of the equipment out that we had here available with your library card. Right now, behind me, if you can tell, I have some of the 3D printers. But I'm going to go ahead and get started with tonight's lesson plan. Actually, let me go ahead and introduce a few things online. I'm going to go ahead and share my screen. Okay, so hopefully you guys can see this. I do have the library's website up. Actually, I have it right now on the events page. I put the link over in the chat too, but if you ever want to get to the shops page, you want to go ahead and click in any one of these equipment and technology guides. Here is our home page. It's got a little introduction about some of the equipment that we have here. And it should also have the lesson plans. So if there is anything that you can learn at home, like the software, we have included the lesson plan here, as well as the activity. It looks like there is another activity listed on here. And then hopefully, again, we'll have this video up very soon. Sorry, one second. I do also want to mention a few things. Where am I? Please feel free to send me any questions that you may have throughout this video in the chat. We do also have my coworker, Tom, who is also on here as a panelist. He will be happy to read through your questions and, you know, keep a hold of that while I go through tonight's activity. If at any point, though, you get lost, feel free to just sit back and watch. But I will be using a website called TinkerCAD that you are also welcome to sort of follow along with the activity with me. So for tonight's class, students who generally take this class have no previous 3D design experience, but tonight we will be using a web-based design software to create solid objects that can be 3D printed. The web-based design software that I'm referring to is TinkerCAD, tinkercad.com. So at the end of tonight's class, most students should be able to modify simple shapes and understand how 3D printers work, understanding their limitations and what they're best for. So there are several different printers out there, or types of 3D printers. The most common is fused deposition modeling, which is what we have here in our shop. FDM, as it's abbreviated, is printers drop and melt or deposit material onto a bed, into a surface, and the models are built layer by layer. Here, let me pick up the computer and show you a little bit. So here we have the Lulzbot. So this is what I'm referring to as the bed, and it will deposit through this nozzle here. It'll drop down one layer at a time, okay? I hope that wasn't too dizzying. So the standard setting for some of these printers for each layer would be 0.1 millimeters, and that is incredibly small. So you are literally building up one layer at a time. 3D printers like these are best for prototyping. If you want to see what an object might look like or a product that you want to build, but it is not good for mass production. So earlier today, I printed one of these. It is a little bow, and it's got these little hooks added on here for putting on your mask. So since we all have to wear one out now that we're out, these could help you alleviate some of the strain from having one of the straps go on your ear, and you're able to hook that onto those little clips here on the side. But this alone is incredibly thin, and it took about 30 minutes to print. So again, not really the best thing for massive prototyping. If you wanted to sell a bunch of things, they would take some time. So you do have to understand that. Here in the shop, we are using PLA. It's the roll of filament you see up there above on the printer. And what this is made out of. It's a cornstarch-based plastic and can brittle over time and has a relatively low melting point. So oddly enough, we tried to use bias tape makers. So there are these little contraptions that help us out with some of our sewing projects. We have printed them out on our 3D printers here. It was relatively fast and inexpensive, but if you do get an iron too close to them, it will melt your 3D printed object. So that's something to think about when you're making models or printing them. I also want to mention that, as I showed you the print bed back there, they do come in different sizes. For example, on the Lulzbot, the one here right behind me, the build plate size is a little less than 30 by 20 and a 16.5 inch space to sort of build. So if you wanted to build something that was bigger, it's still possible, but you will have to print it out as separate different parts and then assemble them later. The other printer that I have here is the MakerBot. I don't know if you can tell, but it is slightly smaller. The print bed size for that is, no, I'm sorry. So that's the one that's about 30 by 20 by 16 inches cube. The Lulzbot is 11 by 11 and about 9.5 inches tall. Another example, where did I put it? Other examples of the differences between these printers, besides obviously their size, are how fast or how precise they can be. So it is a little hard to tell here online. Normally in class we'd be passing these around, but so one of these is printed on one printer and another on the other printer. Some of them have better quality. So for example, this is a little figurine. It does not have a useful function besides it being, cool and decorative. But for example, if you wanted to use this as a figurine to display, whether it's art or it's a game piece, in person at least, you'd be able to tell that this on here, you'd be able to see the lines a little bit more easily. So you'd start to see the little layers that have been built up to make this model. Whereas some of the other printers have nozzles and points that are much that can be smaller, and therefore the layers are not as visible, so it's a lot smoother. There are also obviously techniques for post-production. So once you've printed out your objects, there are ways to obviously smooth some of these layers out and paint them. But so these are two little examples of things that we've printed here with our printers. It is important to note this took about 30 minutes. Something like this could take about, I would say, 18 hours, but it is relatively light. We did make these as hollow as possible so that they would not weigh too much. And they're made out of plastic, but then you have to be wary that you don't get them too close to heat or they will melt. Hopefully that answers a little bit about some of the 3D printers here. I'm going to go ahead and share and go back to sharing my screen for the website TinkerCAD, the one we'll be using tonight to build some of our 3D models. Okay, so hopefully here on the screen you can see I have TinkerCAD brought up. We use TinkerCAD for modeling for beginners especially because it is free, it is cloud-based, which means it's just online, available at any time that you have internet. Let me just finish, I'm sorry. And it's easy to compare different 3D modeling platforms. A lot of the software can be expensive to download. It will have a lot more features, but if you're just getting started, something like TinkerCAD is great. That's available online, and you're able to create an account for free. There is a question in our chat that says, were those models built with TinkerCAD? So these were not. As you can tell, they're a little bit more intricate. So this is actually a figure from a movie. I will show you much later on towards the end how we got these files. First, I'm going to go ahead and introduce some of the basic shapes and modeling, and then we can go ahead and at the end talk about where to go from there. Okay, so hopefully that answers some of it, but a little later on tonight, we'll get to that. So on, check away. Okay, sorry. So you should still also be looking at the TinkerCAD homepage here. To get started for tonight's activity, you would go ahead and create a new design. The intro activity is to create a keychain. Here are some of the past examples of people's keychain. Here is the one from about a month ago when I had this class also. But so here is the TinkerCAD website. To get started, we'll go ahead and create a new design. Something to keep in mind when you're getting started is, so here, the blue box here down in the middle of your screen is the work plane. It is, if you'll notice, the measurements are in millimeters. Something just to think about depending on what printer you are planning on printing it. I'm also just mostly familiar with inches, but if we did it in inches, you'd know that you know how big you're able to go on some of these build plates. So I'm gonna go ahead and leave it to inches. You can actually go ahead and select the type of printer you have. Here behind me, I have a MakerBot replicator. We do usually also have an Ultimaker available in the shop, but the one that I'll be using as an example tonight is the Lulzbot, and that one's actually not listed on here. But just something to keep in mind, you are able to mess with that grid there. I just want to point out a few things. So over here on your right, we've got all of your basic shapes that we'll be using for tonight. And then over here on the left, we've got a lot of our navigational tools. Zoom and zoom out, zoom in and zoom out of your workplace. Once you've created some models or you've put some models on your work plane, you are able to go ahead and center on them. The cube here at the top, if you click and then drag them and drag it, you should be able to see different angles of your work plane and your model. If you'll notice here at the top left, here is your model name. TinkerCAD likes to give these models pretty crazy names, but feel free to just go ahead and save it to something that's more relevant to your project. Normally here, when we're inside the shop and having this class, I would have you guys obviously use your name so that we can keep track of these, plus keychain, and then maybe a color, the color you decide you want to print it. In this case, we'll just go with red. So you are able to keep better track of your projects this way. I'm going to go ahead and demo some of these, navigational and basic shapes that I just showed you. So I'm going to go ahead and place a box anywhere here on the work plane. I went ahead and clicked on the box and dragged it onto my work plane. This here, remember to see the different angles of your screen. Let's see. Click and drag, and so you're able to see even the bottom of the work plane, the sides. Something to keep in mind is to make sure that your object is always on the work plane. Sometimes you can tell that you've maybe moved your item too far down and you can see that it is underneath that work plane, or sometimes it is. Sometimes we can get carried away and it could be that it is floating above your work plane, and that's really going to cause problems when it comes to printing. If it's not on the work plane, if it's not level to the work plane, it either won't print or only print half of your model. So that's something important to keep in mind. You can always click and drag your object anywhere in the work plane, but if you do click on it and then drag some of these little corners out here, you are able to change the dimensions of your shape. But I rely mostly on here, on clicking on there and inserting, the measurement that you want, just so that it snaps into place. So I don't know if you guys noticed just now, but so when I clicked on one of these corners here and dragged it, it looks like it increased both in length and in width. But if we do want to go ahead and keep this a square, or let's say, for example, you've put together different shapes and you want to just make sure that you're scaling it up in size and not just sort of dragging, certain sides and distorting the figure, you can always click down on your shift key on your keyboard, click on that corner again, but this time it should keep everything in proportion, and you'll notice that the cube is now increasing in size, but it's not necessarily, you're not necessarily dragging certain sides of it. That's actually a really important tip to keep, just throughout your modeling. The other important thing to note here is that cone at the top of the shape. Here, let me just click on the front. So this cone up here. You noticed earlier I was sort of messing with that and it was moving the box around. So again, it does allow you to pull the shape up or down into the work plane. Now we can see examples of zooming in and out. Sometimes that can be helpful if you're working on, maybe the face of one of these blocks and you need to zoom in closer, or you want to see your whole object and so you want to zoom out. Home will always revert you right back to that sort of view where your model is center object and it looks like it's a little tilted from the top. Switch perspectives, it looks like, is what this one is. But feel free to play around with these so that you understand what is going on here. I'm going to remind you guys just again to feel free to send any questions you might have to the chat function of Zoom, please. So now that we've gone through a little bit of TinkerCAD, I'm going to go ahead and select and delete this object, and we should we'll get started on tonight's activity. So I'm going to go ahead and move on to the instructions for the keychain for tonight. I'm sorry, give me one moment while I get myself together. So now we are moving over to the instructions for the keychain. Hopefully I am moving between screens and you're able to see what that should look like in just a minute. Okay, so this is kind of what we're looking at. I'm going to go back to TinkerCAD if I can. Sorry, I'm having issues. Okay, so here we are back to TinkerCAD. So again, you want to open up a new project and then feel free to rename your project to something that's more relevant to you that you'll be able to find more easily. In my case, I went ahead and put my first name, the project that we're working on tonight, which is the keychain, and the color that I would like for it to be printed. Step number 3 is to go ahead and select the box shape from the sidebar and place it anywhere on your work plane. We're going to, for number 4, adjust the dimensions of this object to, actually I'm going to go ahead and go back to millimeters just because the instructions are in that. Okay. So with my object selected, I'm going to go ahead and change some of these measurements. So we want it to be 20 millimeters wide, 50 millimeters, oops, excuse me, in that direction. But then when we click on the box at the top, we only want it to be 2 millimeters in height. We want it to be relatively flat. This is going to be a keychain. I'm not sure if I pulled out an example for that. I'll show you guys one hopefully after we finish this activity. But so step number 5 is going to be to select the cylinder over on the sidebar and place it anywhere on your workplace. Number 6 is going to tell you to, I'm going to go ahead and zoom in so I can, oops, excuse me. Zoom in and have the work plane so that I can see what's going on sort of from the top. But so we want to also set this to be 2 millimeters in height. We want it to be the exact same size as the first object we just created. And then I'm going to move it just so that it's right center on the left edge of our rectangle. Oops, excuse me. The next thing we're going to do is, for number 7, we're going to select a separate cylinder hole shape. So if you'll notice when I click on the first cylinder shape that we placed on a work plane, I have selected the solid shape I do actually want that to be printed, you're just as easily allowed to make it a hole. And so you could click on hole and it would make anything in that area sort of disappear. It'll make a little bit more sense once I show you with the second cylinder that we're going to place. So if you'll notice here at the bottom, this was the solid shape. Now we're going to go ahead and select the whole cylinder and drag it into our work plane. So this is going to create the area where normally you would put the key ring on. So we do also want it to be the same height as the rest of our model, 2 millimeters, but we actually only want it to be half the size of our other cylinder. We want to go ahead and create a hole so that, oops, excuse me. We're trying to create that hole that's going to be the space for the key ring to go in. So here I went ahead and placed it sort of in the middle of our other cylinder. So if you'll notice, I had a bit of a problem centering all of these shapes. So once you have your cylinder hole right over your other cylinder, we are able to center these. I can't quite remember. I think it's this icon here at the top right to align them. In the other example that I had on the homepage that I had done last night was if you want to play around with some of these other shapes, let's say for example, if I didn't want to just make it a regular circle for the key ring, if I wanted, for example, to make it a star, I could click on that one, drag it onto my work plane, make it 2 millimeters tall, just like the rest of the objects on there. And make it so that it fits on there. So this is a little bit more customized. Instead of just getting a plain hole for your key ring, you can go ahead and lay down something that's, going to be a hole in the shape of a star. And then here you also see that originally I had selected the solid shape, but because I want this to be a hole, I'm going to go ahead and select hole. Oops, excuse me, the wrong shape was selected. If you do make a mistake, you do always just want to go ahead and click undo. You're welcome to do that on your computer or up here on the top left. These are really going to be your best friends. I constantly just click undo for any mistakes I'm making. So now that I have the star selected, I'm going to go ahead and click on hole, and you'll notice that it'll eliminate anything inside that shape. So that is the beginning part of our keychain. In order to get a little bit more familiar with the other basic shapes here on TinkerCAD and to customize this a little bit more, we would go ahead and have you insert text and numbers. So right now I'm going to go ahead and click on the text feature. I'm going to go ahead and drag it onto our work plane just anywhere for now while we edit this. When you lay down the text shape, you'll also get the little menu that allows you to customize what the text actually says. In the class like tonight, we'd have you put, your name, your nickname, whatever it is that you wanted to say on your keychain. So in my case, I'd put down my name. And you can also change, your dimensions here. But again, I prefer to use this. So instead of it being 2 millimeters, I don't want it to sort of like lay into our keychain shape. I want it to be slightly raised so that you're able to see the name, and so we're going to make it 3 millimeters tall. Then I'm going to go ahead and drag it over onto my keychain. It's obviously too big, so I'm going to go ahead and while my name is still selected, I'm going to go ahead and hold down the Shift key, grab one of these corners, because I want my name to, I want to make it smaller, but I don't want to sort of distort the text. I want to just make sure it stays proportionate. So I'm going to go ahead, click down Shift, and make this slightly smaller. Oops, excuse me. Somehow I've made this not quite as tall. Here you go. So I've made a mistake. I'm going to go ahead and undo. I'm going to go back to select my name, hold down the Shift key, and try to make this even smaller so that it fits within this area here on our keychain. Okay, so there is my name. The last thing you're going to want to do on TinkerCAD, and you want to make sure you do before you send any of your files to the 3D printers, is to go ahead and select all the shapes. You are obviously able to click and drag a box around the entire object you're working on. You can also hold down the Control key plus the A to select all the shapes on your work plane. If you do accidentally sort of just select one, like let's say, for example, I just select my name. When I go over to export it, unfortunately, the only thing that will be exported will be my name. So this is why we want to make sure that we combine all of our shapes, what we call grouping in this case. So I'm going to go ahead and click Control A, and then over at the top right, this is the feature you're going to want to use. Control G, or go ahead and select this grouping. You'll notice that all of these became one shape. So right now when you're looking at the screen on TinkerCAD, you are seeing sort of these shapes and these colors. You are able to, in the menu, you're able to sort of customize that, so I can have it appear to be, light purple if I wanted it to. But it's important to note that the only way you'll choose the color is dependent on the reel of filament that you've placed in your 3D printer. So this light purple is not going to actually mean anything when I export it and send it to the printer. So that's something to keep in mind. But for example, here is the keychain. It's quite small. It's got my name. It's got a hole for the key ring. Everything looks good. I'm going to go ahead and export it. Here at the top right, we'll click export. There are quite a few different file options. We're going to go with OBJ. That is normally the file type that we work with here in the shop. It has slightly less instructions than perhaps an STL. Oh wait, no, I'm sorry. I've been mistaken. We usually download the STL format of our files. OBJ is the one that I think has a little bit more information about your 3D design and has a little bit more information on what's going on around it, whereas the STL will be just a file type of just the object that you've worked on. So I went ahead and downloaded the keychain. Oh, and I called it red, but I ended up making it purple. But so in class, This is normally where we would have finished with our activity. And then normally when you're in class, you are logged into the shop's account for TinkerCAD. So you would just make sure that when you hit the home page, your project is saved onto that home. That home page with all the other projects. So here you'll see the latest project I created was a keychain with my name, and then with a little keyhole in the shape of a star. So now I'm actually going to bring up, oh, looks like we have one more chat. Oh, Tom did a really good job of explaining some of the different file types in the chat. So feel free to look at that. And earlier in tonight's sort of class, we had a question about building, which the models I showed for example. So let me go ahead and unshare my screen. Okay, sorry, couldn't see myself. So earlier in tonight's class, I showed you 2 examples of things that we've printed here. These obviously were not made using TinkerCAD. I guess you could build something quite intricate in TinkerCAD. It would take much longer. These little figurines here that we've printed, at the bottom is the printer that they were printed on. These figurines here were downloaded from a site called Thingiverse. I'm actually going to go ahead and go back to sharing my screen. Sorry about that. Talk a little bit about Thingiverse. So Thingiverse is another great site we use a lot here, especially for people who've just started out with 3D printing, 3D design. Thingiverse has a collection of 3D files that have been uploaded and are available to download for free. People are usually customizing, specific figurines. You are able to, let's go, for example, if you wanted to print out a Baby Yoda, people will make the actual files available here for you to download either as an OBJ or an STL. Usually they'll give you a few of the print settings, which is incredibly helpful when you're getting started. Things like infill. Infill really has to do with how hollow your shape is. Though whether it needs supports or not is incredibly helpful too. But so people will download these. Sometimes they will mess with them in their own modeling software and upload them. So this site is incredibly helpful for when you're just getting started. If you want to see, for example, what a little figurine would look like, we did get them from Thingiverse. So this group, for example. Actually, I think tonight the mask strap that I had printed was something that I got off of Thingiverse. So I'll use that as an example to show you what it's like to sort of download some of these files. So here it gives you a little preview. There is only one file, which is nice. Some of the shapes on here or some of the figures can be quite complicated, and so there'll be several different files, but in this case, it's just this one. So I'm gonna go ahead and download it and check the chat one more time. I mentioned that the printer prints at 1mm resolution. Is that the precision as well? That is, I designed something that is 0.6mm thick. Will the printing, while printing, or is there variance? There can be. So in the chat, we have a question about how accurate that 1mm sort of resolution is. So there are two things to keep in mind. The first one is in your software, you want to make sure that that is sort of like the unit of measure you're using. So I would go ahead and select 0.01, but it's also important to note that on the printer itself, the nozzle down there, I don't know if you can tell, pointing right at it, that nozzle, those are interchangeable, so there are different sizes. If you wanted to keep it sort of to scale, you would go ahead and just leave it at 0.1, but you are able to change out those nozzles, so that could really interfere with the accuracy of your printing and your modeling. Let me go back to, where was I? So I had downloaded these files, the mass strap I had in the example, but I'm going to go ahead and open it now. Sorry, bear with me while I try to share all these different screens. So when I click on the file I downloaded for the Hello Kitty mass strap, it did automatically want to open up on MakerBot. And so I'll show you what that looks like on there. Right now it's working on inserting that file. Puts it right on the work plane. Some of the nice things that people had posted online refer to the infill again, whether it needed supports or not. Those are things that we sort of get into the more you get, into 3D design. It's not quite as important for this class. We, the staff members, are the ones that really handle the printers. So we would go ahead and print your files, your Keychain files. But so for example, I can't remember what it said on Thingiverse. Give me 1 second. It said that I did not need supports. And it does not give me any sort of infill advice. But so this is what it looks like on MakerBot. MakerBot is the printer here on this side of me. It's important to note that the build plate for the MakerBot does come out. It makes it so that your model can, you can snap your model off of the build plate a lot more easily, which is really great. But then you'll notice that this is also plastic and it does not heat up while it's printing. And so it will create what's called the raft. It will automatically create something that's called the raft that you will have to take off of your model. The Rollsbot, on the other hand, has a glass build plate, which does actually heat up. So this is actually really warm to the touch. And so your model is able to adhere much better to the build plate, but it will be kind of tricky to sort of peel this off the build plate once you're done. Let me show you an example of something else called supports. Oops, excuse me. So this is an example of something that we 3D printed back when we were open. This is a patron's request. So if you'll notice, it's a little hard to see the whole object there. But so normally the MakerBot will print a raft. It's something that you will have to detach from your actual model. And so this can be a little bit wasteful. But then also, depending on your object, if some things are hanging over, you will have these things called support. They should snap off fairly easy, but it is something that you're going to have to work on after you've printed it. The Hello Kitty mask trap that I printed is fairly flat, and so that's not something I had to do. But another thing to keep in mind, normally when you're in class, you always have all the software for the printers available here in the shop. So Cura would be the corresponding software to this printer here. We obviously have a MakerBot slicing software for the MakerBot, but so this is what it would look like for the LulzBot. Here's where I'd put the infill. Let me see if I can try and open up that mask trap on Cura. So open file. I can't remember what the name was. Yeah, okay, so it's this one. So I went and opened that up. It opens right up on the build plate. For example, I'm going to go ahead and put 100% infill, so I want this to be a solid object. Once we've put that in there, LulzBot is really nice. It tells you down at the bottom how long, the estimate amount of time it'll take to print, and about how much it'll weigh. These are really important things when you come into the shop, because, let me stop sharing my screen. These things are important when you come into the shop, because if there is something that you're interested in having printed, you would normally have to come in person and drop off your file. At that time, we're able to upload your file into something like that slicing software, give you an estimate of how long it would take to print, and how much it would cost. There are little, I think these are also available on the website themselves. Little flyers that we have with some helpful information. So on here, if you wanted to use one of our 3D printers, or if you wanted to 3D print something, you'd create and download your design. You'd have it saved as an STL file ready for when you're visiting here in person. We'd load it into one of the slicers, and then we'd get to see what some of the settings would look like. And then we were printing them in the order that we were receiving. So there was just really a queue that we would put you on. You would not be able to, unfortunately, handle these printers yourselves. We'd be loading people's jobs constantly. But once it is printed and completed, we would contact you to let you know that it's ready for pickup. Hopefully before we print it, we'd give you an estimate about how much it would weigh. Right now, printing costs are set to 5 cents per gram. And so if this weighed 3 grams, I think it cost me about 15 cents to print this mask strap. So that gives you a little idea of the printing process here. On the little flyer itself, there is also some of the websites that we've used. Like tonight, we've used TinkerCAD to create your file. There is also SketchUp, which is available online for free, and SolidWorks. I did show you a Thingiverse, which has already uploaded files that you can easily download, tinker with, or just print straight off. There are others. There's one called GrabCAD and Sketchfab. Looks like we have one more question. Can we drop off files now, or is the print lab closed due to COVID? So unfortunately, printing has been suspended. The only services available right now are holds pickup here at Central in the auditorium. Right now, we've suspended both classes in person and some of the printing services indefinitely. So sorry, but just sort of trying to give you an idea of what that would be like if or when we're open again. Does SolidWorks have a free version? To be honest with you, I have not used SolidWorks, but most things have sort of a, I don't want to say free, but like a trial even. I think at one point we were able to download Fusion 360 here as like a student as a student trial, and so it was something that we had here available on the computers, but let's see. I'm not quite sure about SolidWorks, to be honest with you. I think there is a temporary trial or a limited trial. I'm not quite sure how long it lasts though. But another quick thing I want to mention about TinkerCAD, hope you're able to see that on screen, is that over at the top right, there is a link to learn. They themselves have put up little tutorials for getting started, as well as lesson plans and some small projects that you can work through on TinkerCAD. So if you wanted to go ahead and keep learning, keep practicing some of these modeling activities, you could go ahead and try those out at home, but let's see. I'm not quite sure how long this trial lasts, but it looks like maybe you can. Yeah, Tom also included down in the chat, I believe the most they offer is a free trial period. But that was a really good question. Since a lot of people are just, a lot of the people that we see here at the library are just getting started, TinkerCAD really has, I realize it's really, really simple, but you are able to build up quite a bit. And it's, the free and easiest way to sort of have files or be able to create files that you can then print. So we've gone through today's activity. If you guys have any other questions, please feel free to put them in the chat. I'm going to go ahead and hang around just a few more minutes. Thank you so much for joining us tonight. I do also want to mention that we are available on social media. So here, one second. We should have this tutorial up on the website pretty soon. The instructions and the activity are also available there if you want to share that with anyone or try this at home. But I do also want to mention that you can follow us on Instagram. Tom, who was handling some of our tech tonight, is pictured here. Here is his Instagram. It is apl.makertom. He has in the past, at least monthly, he teaches the introduction to sewing. And so here you'll see the example of the little bag that he's created, as well as some of the work he was doing throughout COVID for making masks for personal protective equipment for people who needed them.
Hey, Gabby, you mind if I just jump in real quick? I just want to remind the attendees, if you are interested in some of our other maker programming, you can find that also on our website. And I believe next week we're going to be doing intermediate sewing for making a quilt block. Is that correct?
Yes, that will actually also be me. So there will be another sewing project to join us next week. I also want to show you guys we are available on Twitter. The library has their own individual page. I have my own individual page on here too, but you can usually find us retweeted or latest information here on our Twitter. That is all. I'm going to go ahead and stick around again for a few more minutes if you guys have any more questions. But thank you so much for attending tonight, and please feel free to get in contact with us. Our website our email should also be on our website. If it's not, I'm going to go ahead and put it here on the chat. It is libmakers@arlingtonva.com. Oops, excuse me, that wasn't with everyone. libmakers@arlingtonva.com. arlingtonva.com. Yeah, if you have any questions, please feel free to send them to us. We're happy to answer. But unfortunately, I will remind you guys, 3D printing services have been suspended due to COVID. So we will let you know when that is available again. But thank you so much for attending tonight's class. Have a good night.